Hi everyone. In this talk, we're going to explore how to rigorously evaluate systems where humans and AI work together. We're going to be comparing intrinsic and extrinsic evaluations, and we're going to discuss what each of these reveals and highlight why human-centered metrics are essential for understanding real-world effectiveness. So let's start with the basics. What do we actually mean by human-AI interaction? Well, at its core, it's simply a field that studies how humans and AI interact. On the one side, we have humans, that could mean AI researchers, model developers, domain experts. And on the other side, we have AI systems themselves. So this can include things like large language models, dialogue assistants, translation tools, things like that. And the interaction between the two can take many different forms. For example, humans can collaborate with AI. They can use it simply as an assistant, or they can even analyze how it behaves, and the list kind of goes on. So now that we know basically what human AI interaction is, let's zoom in on collaboration. So collaboration is a bit different. It's about cooperation and coordination between humans and AI systems to solve complex problems or achieve specific goals. And the thing to note here is that most collaborators are not necessarily AI experts. They might be writers, doctors, teachers, or policymakers. And it's people who are using AI more so as a partner, not a black box. This example here shows what collaboration might look like in a creative writing task. The human might start out by writing a story, and then the AI system might offer some suggestions or ideas that build on or improve what's already written. And then finally, the human can provide edits and integrate the suggestions that the AI system provides. It's kind of like a loop where the human writes, then gets input from the system, and then revises, and both sides contribute something unique. This idea also raises some important questions when these systems are deployed in real-world settings, which is how exactly are we supposed to evaluate them and know that they're serving the highest utility for the end user. And before we get into that, what exactly does human AI collaboration generally look like? On the left, we have models, which are usually good at fast and local text generation, and they look at the last few sentences and kind of predict what comes next, and they produce something that's coherent almost instantly. So in a writing workflow, the model can share things like suggesting the next sentence or helping you overcome writer's block. And on the right, we could have a human where the human brings unique strengths that the model might struggle with. So for example, long-range reasoning, more global coherence, and providing a clear sense of intent or creative ideas. And humans really know what the big picture is. They know what they want to say, the tone that they want, things like that. So their role in such a system would be more so to lead the writing and decide, what the direction is. And what we're aiming for in the middle is a combination of these two strengths, or more so a collaboration, where the model accelerates more so the mechanical parts of creative writing, and the human might guide the overall logic and purpose. And the ideal collaboration happens when humans and AI each contribute their unique strengths by combining human reasoning and intent with AI systems' fast text generation at a large scale. So that brings us to this question of what exactly should we be measuring in order to evaluate the effectiveness of human AI collaborative systems? And we usually start with these three classic usability dimensions, namely effectiveness, efficiency, and satisfaction. And these were originally adapted from Bevan et al. Into 2016 paper. Effectiveness is all about accuracy and completeness. Did the user actually achieve their goal? Efficiency more so looks at the amount of resources that were spent. So the time, the cognitive effort, maybe the number of interactions that it took to actually reach that goal. And satisfaction captures the subjective experience. So was the process smooth? Was it trustworthy? Or did the human even enjoy collaborating with the AI system? And that brings us to trade-offs. What's interesting is that all three of these dimensions often pull against each other. For instance, fully automated systems may look more efficient on paper, but users often find them as less trustworthy or harder to control. And a large part of evaluation means we have to decide which of these goals actually matters in the specific context that we're operating in. Here's a nice concrete example from a paper that was published at ACL 2023. And on the left, we see a reference code snippet and a model-generated one. And the generated code actually fails the unit tests. So functionally, it's incorrect, but it actually was still rated highly by the programmers because it reduced the overall effort needed to actually fix the problem. And in other words, this was a quote taken directly from the paper. Even when effectiveness is low, efficiency and satisfaction can be high. So the code was almost right, and it was easy to debug, and it helped the user reach their goal faster. And this highlights this important point for evaluating human AI systems, is that we need to consider multiple metrics, and the system's value isn't always captured by just the correctness alone. It also could depend on how much human effort it saves along the way. So now that we've discussed what exactly we should evaluate, let's take a look at how these evaluations are actually carried out in practice. So in general, we can think of two main approaches in evaluation: quantitative and qualitative evaluations. Quantitative methods help us understand what things can be counted, measured, and compared precisely. So for example, how many questions did the model answer correctly? Did the user complete the task? How long did it take? Things like that. And qualitative methods, on the other hand, help us understand the why. So they're more open-ended, and here we ask questions like, why did the user struggle here? What did they like about the experience? What led to their frustration? And there's also different types of evaluations, so namely intrinsic and extrinsic evaluations. Intrinsic evaluations ask, how's the model doing by itself? So it focuses on more specific benchmarks or tasks. And extrinsic evaluation, on the other hand, asks, how helpful is the model in the real world? And it measures performance in context. So for example, how much the model actually helps users complete a task or make better decisions. An example of intrinsic evaluation, we can look at the toxic classification accuracy system. So intrinsic evaluations inherently measure a model's performance directly without any human in the loop. So for toxicity detection, we have well-known benchmarks like the Jigsaw toxic comment dataset, Civil comments, the Perspective API datasets, and all of these datasets consist of online comments that are labeled for categories like insult, threat, identity attack, profanity, and so on. And the model's job is simply to take an input text and output toxicity scores, like the example that we're seeing on the right here. And to evaluate how well the model is doing, we can use these intrinsic quantitative metrics like AUC, F1 score, and precision and recall, which can tell us how accurate and how sensitive the classifier is. And the point here is that this type of evaluation focuses purely on the model's internal classification accuracy and not necessarily how humans interact with it. So, for example, even if the model has a high AUC or F1 on these particular benchmarks, we would say that it performs well intrinsically, and we might not have a good idea of how that would translate to better outcomes in real-world use. So that's exactly where extrinsic metrics come in. Here's an example of extrinsic evaluation, and this time we can look at language models as writing assistants. So unlike intrinsic metrics where we evaluate the model in isolation, extrinsic evaluation measures how the model impacts real users performing real tasks. So in this case, researchers ran a controlled user study to understand how different language models affect people's writing outcomes, and they looked at three main types of user-centered metrics. Namely, they looked at task success. So did people actually produce a higher quality final paragraph when they had access to the model? They also looked at time to completion. And lastly, they also looked at perceived usefulness. So did the users feel good about using the tool? What did it make their task easier? Did it make their task clearer, faster from their perspective? Things like that. And the charts at the bottom here give us examples from these prior studies showing how people use AI tools in different writing-related contexts. So the key idea here is that one single evaluation metric on its own does not give us the full picture. It's in fact multiple kinds of evaluations that give us a full picture of how a human AI collaborative system would perform in the real world.